those combination of all of those conversations that happen between the client and the server sum up to what is called a session. So whenever a page is accessed or whenever a web um, client attempts to interact with the web service using the protocol HTTP, there are series of transactions that occur between them, and that put together is called the session. So let's dive into it today, since we're going to be looking at dealing with the rest of it and concluding perhaps in this chapter today. No matter what happens, even if we don't, the rest of it is going to be what you have to do on your own end. So a web session is a sequence of requests that are made between a web client and a server. And these conversations are more or less like a transaction. Why is a transaction? Is because there's what you give for what you get, which is usually like a request. So these transactions include anything that has to do with before you are authenticated or pre-authentication tasks, then the process itself of authentication. Now, once you're authenticated and given authorization to access whatever resource, a session is actually activated. That session is maintained or managed, and then access to that particular session is also controlled. And then in the event that everything is concluded and you are done, which is where either a reset request is sent or a finish request is sent, then the session is finalized. So all web applications that we have to, in some way, be able to identify this conversation. This is, I'll always say this again. This is why penetration testers will need to look at it, or even any cybersecurity person will need to look at this critically, considering that these conversations that occur between the client and the server would have to be kept for the purpose of managing that session. That conversation must be kept. And then for how long it is kept. This is where we have things like what do you call it now? Cookies, right? And there are two categories of them. There's a persistent and non-persistent cookie. And the difference is just that one of them is kept for a long time, the other one is terminated the moment the web session ends, or when once you turn off the browser or exit the browser. So these web applications that we have today have to keep track of information about each user for as long as that transaction is going on. Several web applications have the ability to establish um, different um, credentials or information that allows access to some services. And this usually could be, global or localized, meaning that I could actually sit on a server or sit on a client and attempt to log in into a particular device, and they may require certain character for me to be able to log in. Could be a particular identity given to me, could be a username, could be an email address, could be whatever, right? And all of these inputs, right, need to be validated, right? Because it's part of all the building of the web application. There must be what's called a valid validation for every input. Now, since we're going to be sending requests and, of course, getting access to the server, the web applications have a tendency, the applications, of course, in their structure or in their build-up, can create and keep track of any form of user details. And this could be known or unknown, whether anonymous users who are trying that for the very first time or people who have been doing that. So, for example, you can say an application can, have a way of identifying your preferences when you joined. Could be things like, let's say, the number of times you visit, when you visit, the theme that you use, your preference of language, right? And perhaps you visited with a mobile device or maybe with a web device and all of those. So there are things that these particular conversations, because web applications need to keep track of them, there are things that they do. So it allows the application itself, right, to be able to identify any user. So after you log in for the first time, it keeps track. This is where cookies come in, right? This is where sometimes people are told to clear cookies or be able to, you know, um, excuse me, give me one moment, please. Apologies for that break in transmission. I got a call. I just needed to deal with that. All right. So this track that this keeping tab on the conversations between server and client that the applications do allows the application to be able to identify any user each time the person arrives there. So say with respect to authorization, like a list of what you're permitted to do within that site is usually kept. Now, very dangerous. That is why we always tell people that if you're using a device that is a public device or a device that more than one person accesses, ensure that you don't allow it keep track of all of this. How do you do that? You clear. Because sometimes browsers prompt you. There's something that allows you to update credentials like username and passwords and keeps them. These are just part of it, right? A large number of it includes preferences on the site, things that you did, how long you stayed for, things you spent more time on and all. The reason why this is so is because most web application developers need to do some level of analytics with respect to the number of what's it called now? Why am I forgetting words easily? The demographic of people who access the websites, and for how long. So they're able to use that to do some form of targeted service delivery. So web applications are able to provide session capabilities for both before and after authentication on the basis of this. So every session that we have, right, right, as established, would need to be sort of tracked. To be able to also identify that these tracked sessions are unique, right, and are specific to certain users, there must be a way to identify them with what we know as a session ID. Some people call it a token. It's temporarily equivalent to the strongest authentication method used by the application. And the reason is because it keeps track of things like username, digital certificates, for a particular user, and so on. Now, in order to keep the authenticated state and track user progress, applications provide users with these session IDs or tokens. Now, what is a token? Simply is an assigned value at the creation of a session. Once the session is created, it is allocated to it. This particular ID is very important for analytics. Very important. Why? Because at the point when I say analytics now, this is when you get captures like what we did yesterday using Wireshark, for example. I can actually tell you to identify a session number, a particular session number. It helps you to track what that conversation is. A session ID would be consistent for every form of conversation that occurs between a client and a service or a server. So what might be different now would be perhaps be the various kind of packets generated or information generated by each of those contacts that make synchronization, acknowledgement, and the rest of them, just for the few of them. So the session is assigned and it is shared and exchanged by the user and the application while this is happening. Why? That's why it is unique. So I can get a particular session ID. They may have like 27 um, transactions or conversations. And if I use a particular session ID, I can lock all of them together and be able to tell the time that this conversation occurred between the client and the server. Very important. So it could be PHP, it could be JSON, whatever, right? In addition to the session ID name, there is a way to identify that this particular session ID or this application that we're using was built using either PHP or built using whatever programming language, right? So it is recommended to change the default session ID name of the web development framework. So each time people do stuff, the generic name is ID, right? So if people build web applications, the advice is for them to, that's for the guys who build it. Let's focus on what we're looking at here. So it is very important that the session ID be unique and unpredictable. So there is a framework for it, which is called the deterministic random bit generator. That is what people should actually embed into applications to be web applications, that is, to be able to help create a session ID value for each transaction that occur. So quite a number of mechanisms are available. Remember, we talked about get, we talked about post. Post, of course, being when you're able to from the user's point of view when it's trying to send data to a server. Why this is very important, we're going to look at it very shortly with respect to the various types of attacks that occur. You must have heard about cross-site scripting, XSS, or even SQL injection. All of these are very dangerous and it works in a very interesting way. it's not usually like very, perhaps because a lot of people don't pay attention to the structures of the web applications or the structures that build up the web applications, it becomes a little bit sort of tricky to identify. Why do I say so? Every web application have what is called an input value. This input value is usually what is expected for the client to add that the database would have to compare to find out if this user is valid. For example, when you log onto your Cisco site, if you attempt to put in a value less than what you normally should put, let's assume that your username is Ochepo, right? And you don't put Ochepo, you put Ochepau, right? Now you have imputed a value. However, against the database, at the point where you impute the value and hit enter, that entry must be validated against the database. That's where most of the trick occurs. So at the point of validating against the database, there's an interaction with your entry and the database, which is usually where some of it are dumped, right? So once they are dumped in the database, it could be there and be running until another person attempts to interact with that database, and then it injects it into their site. And this becomes a script that is loaded. Now, I give an example with Ochapol, which is just like something very, very regular. You can just assume somebody has the skill to impute certain actionable script, right? Let me give you a real life scenario of what happened. I'm sure some of you have heard about Stuxnet, and that happened. PCL, they have this centrifuge. Stuxnet is actually a cyber attack that occurred in Iran. Till today, I'm sure there are a lot of what's it called? There are a lot of conspiracy theories as regards who did it, who didn't do it. There are lots of documentaries around, right? There's a movie called um, what's it called? Zero Day Attack. It allows for different people to actually suggest, based on their own conspiracy theories, that this what occurred, right? But arguably, it is believed that a part of the world, which is Iran, could not have been having nuclear warheads, right, or nuclear reactor plants. And so they wanted to just demolish it. And now it dates back to way back when I think it was President Nixon also, in a bid to establish some relationship with that aspect, that side of the world, gave them a gift of a nuclear reactor, which they studied carefully and modified. In modifying it, they were able to now build a lot. Unknown to them, it was after a quite long time that they realized that these guys were expanding on their stuff. So those collaborations thought of, hey, or these coalitions thought of, look, let's break these guys. And they didn't know how to make this happen. This I'm telling you is a how do I put now? A variation of it is captured in the movie Kandahar. So if you watch movies, look at the movie, you identify someone. They didn't pick the focus more on the action of the shooting and all of this, but the core of the story is a nation, right, was getting very powerful with respect to nuclear reactors. And they wanted to just cripple them. And the only way to do it was to do it on site. But they couldn't do it if you're going to have to be accessing them because immigration laws were not very friendly with all of them, right? So what they did was that they observed after studying that the components, I'm trying to explain how some of this ingestion occur. The components that they used in building it contain certain regular computer parts. There's what is called the programming, the program, not programming, printer command language, a PCL, which is usually used as the guy who helps to interpret how a physical component works. This is where the scripts actually interact. What they did there was a very simple thing. The centrifuge moves at a particular revolution per second, and it had to do 2 revolutions per second. Say, for example, all they did was to change a script. It was in an update. So these guys went on site to do some work and updated that PCL so that that particular patch was added to the PCL, which controlled the centrifuge to be rotating. Now, somebody can say this is an attack. Of course, we know it was an attack, but it was done using IT things. How? They identified the interactions that this client has with its server, which is normally what it updates it. Now, please note that server was not online. Because of course these guys were completely offline. So they sent some guys there to add some stuff and they eventually damaged it. So typically, right, devices, well, good thing was that they arrested it early and it didn't cause World War. So session IDs are very important. It is used to identify conversations occurring between client and servers. Now, including the session ID in the URL can lead to the manipulation of the ID or session fixation attacks. It is therefore important to keep the session ID out of the URL, which is usually what you need to write in the script, indicating, right, that this should not be added, right? So it may not be obvious. It could be obvious, if you look at a particular stretch of command that is extracted from any session, you may notice the session ID attached to. But then most of the tools that we use, example, Wireshark has a way of pulling down those stuff. So the use of an encrypted communication channel also protects the session against some session fixation attack, in which the attacker is able to intercept, right, every interaction. And of course, remember that these interactions are kept, right? These interactions that are kept are what gives rise to what we call cookies. So session management mechanism based on cookies can make use of two types. Of course, we have the non-persistent and the persistent cookie. And the idea is just simple. Some non-persistent mean that it won't be there for too long. The moment you shut down the browser, everything goes off, right? Every cookie or every session discussion that is occurring between the client and the server, which is expected to be kept by the application, all of those things terminate. And the ones they terminate, of course, keeping track will be hard. Except, of course, you're able to sniff it and then observe the behavioral pattern and prepare for it to happen. So if a cookie has a max age, or expire value attribute, it is considered a persistent cookie and is stored on the disk by the web browser until the expiration time, which could be maybe after the next update, right? But most applications today, what people are doing now is to ensure that session IDs are actually determinate after the web browser is closed. For those of you guys who have used computers for a while, if you remember back in the day, you can be doing a download and network can interrupt and you can come back and continue. But that doesn't happen these days anymore. The moment there's a fluctuation in your network connection, you are going to have to start all over again because it is perceived as perhaps somebody trying to, do some form of funny infiltration into that particular place. Right? So let's go on. I'm going to be jumping through a lot of stuff. Some of them are what you're going to be dealing with. So modern applications typically track users after authentication by using non-persistent cookies. This forces the session information to be deleted from the client if the current web browser instance is closed. Or let me put it this way, if the instance of the session is interrupted. That's actually a better way to put it, right? So that is why it is important to use non-persistent cookies. The session ID does not remain on the web client cache for a long period of time, so that way you cannot keep track. So in a way, it makes it a little bit tough for somebody to actually track as somebody attempting to perhaps monitor the network. However, the important part of it is that it reduces the possibility of any penetration tester or any threat actor from gaining to full access. So session IDs must be carefully validated and verified by an application. So this valid input or input validation is a very important thing. It's simply saying that the web application always provides some form of interface for you to impute certain characters, which must be validated against the database, usually maybe SQL, right? And the rest of them. So typically, the database would have to check with what you have entered to verify if that value is what is in its database. And it will do a check from top to bottom or bottom to top, depending on how it does it. In doing that, you may not be able to tell that that particular character is actually a script, an executable script that upon interaction with the database is now added to the database. So typically, one thing that people who do web applications are expected to do is to ensure that there's what is called input validation. Simply saying there are certain characters that should be considered the only thing. So it should not continue searching database, except of course the characters are valid. Certain things, for example, if you say it's a male, they are putting then there should be an at, right? Dot something, a username at a particular domain dot a particular, like that. If it's a character, it could be maybe 8 characters. Some people have this what's it called now? Have this not restriction, I have this recommendation. Is it recommendation? they have this like a standard. It shouldn't be more than a particular, should be less than a particular number, and so on. So if web applications do not validate and filter out invalid session ID values, they can potentially be used to exploit other web vulnerabilities such as the SQL injection. So, and of course, cross-site scripting. So the both of them they are similar. The difference here is that SQL injection actually attacks the database. Cross-site scripting allows certain inputs to be launched into another web page, right? So it actually, whoever comes to that particular web page can go with some script, and by so doing, it could be just initiated by a command and control, and somebody sits somewhere and have his code, running on certain people's websites and all. So the IDs are stored and reflected back after the web application. So typically, that's what cross-site scripting is. Now, the Open Web Security Project, or the OWASP, is an international organization dedicated to educating industry professionals, creating tools, and evangelizing best practices for securing web application and their underlying system. OWASP publishes and regularly updates a list of the top 10 application security risks. We talked about those yesterday. And it's an awareness document and a community effort. So again, it is typically like, how we noticed this thing that was good in January is not working anymore. Let's update the list. So the best way to keep up to OWASP update is by navigating directly to his website. And that's the website. And there are 10 of it, right? I read them out to us yesterday. So this particular module covers vulnerabilities in the OWASP top 10, such as injection vulnerabilities and cross-site scripting. So let's dive into it. This is like a, what's it called? A lab, which I'd advise. This is just as good as going to use a particular tool, which is called Nikto, to perform basic scan, and use use the web scan to check and identify vulnerabilities that exist in websites. Okay, so you export Nikto result to a file, then be able to look at all of those. Then there's a GVM vulnerability scanner. Okay, to take some time and can take more than 30 minutes to complete. So attempt doing that and please try them. Right. So let's go to how to build your lab and see what we can achieve with that today. With how to build your lab. In module 10, which is what we have as the tools and code analysis, you will learn details about dozens of penetration testing tools. So we're getting there. I know a lot of people are actually itching, and some people amongst you here have been doing this for a while. So what we're talking about right now could be boring. The interesting part of it is that as boring as it is, it would be good to actually take a look at it again. And so that you understand what your tools are working on, right? So those tools are not just tools that can be used without identifying what they're working on. While we're taking time to explain what occurs between a client and a web page or a server, is that this is usually where attackers launch their or threat actors launch their attacks. Now, again, I'll say this always until it becomes like a song, until perhaps if, when you see me on the street, you realize I was saying, the internet architecture is such that it is built with the server client model. What does that mean? It means that as long as it is a network, there are services to enjoy. Users join network to enjoy services. Now, if the service is going to be available, somebody is serving the service. Some person is making a request for the service. That is where most of the attack is focused. So there are conversations that occur between the client and the server, right? This is usually where most of the attacks are targeted, are identified, right? So some of them take advantage of this conversation. They sometimes imitate the client, other times they imitate the server in the response. So other times they can't come in the middle and hijack the conversation that is happening between them. Okay? So this section provides some tips and instruction on how you can build your own lab for web application penetration testing, including deploying internationally vulnerable application in a safe environment. So remember, that is why we discussed this. Part of why sometimes it is safer to have this kind of classes in person is because we can have a lab in a room. Remember, we're using an application online. We don't know all of us. While most of the penetration testing tools covered in this course can be downloaded in isolation, and installed in many different operating systems. Several popular security-related Linux distribution package, hundreds of tools are available, right? So that is why most times you hear people talk about Kali, right? Kali has embedded in it a lot of these tools that you can use to identify how safe or how much you can do. Kali Linux is probably the most popular security penetrating testing distros, right, of all the ones that we have. We have there's a lot of them. There's Parrot, yeah. Parrot operating system is also a Linux distribution or a distros. There's okay, so there. So the following are the three most popular Linux distribution for ethical hacking. So there's Kali Linux, right? Is a Debian-based distribution primarily supported and maintained by Offensive Security, and it can be downloaded from www.kali.org. Okay, you can easily install it on your device, which is the bare metal system, or you can go ahead and get the OVA. The OVA is the Open Virtualization Appliance, where you can install in a virtual machine environment and even install on devices like your Raspberry Pi, which is those tiny devices that they use a lot to automate some of these attacks, or Chromebook. And the Sparrow OS is another popular Linux distros or distribution. Is used by many pen testers and security researchers. You can also install it on your device, just like how one of us tried that. He said he was trying to do some virtualization and his system would not allow it, owing to the processor capacity or the processor structure. And he was able to do it on a partition. And so you can download Parrot on www.parrotsec.org. Then there's your Black Arc Linux. It's becoming popular. It became very popular from the um, I think 2000, right? Is based on Arch Linux and comes with more than 1,900 different tools. Now, we have a thing in this part of the world of always just gathering stuff and not using it and just boasting that you have all. So when somebody discusses as regards these tools, you are able to say, I have it. But the thing is, I believe in, even if it's an outdated one that you have, master it. No, that's my belief. Know how to use the one that you have. So you can download Black Arc from Linux from http.blackarc.org, right? So there are several internationally vulnerable applications and virtual machines that can deploy in a lab environment to practice your skill. So um, GitHub is where most developers are. It's a community of developers. You can run some of them in Docker containers, right? Omar Santos, which is, if you observe, most of what we're doing is based on his work. He has included in his GitHub repository, and that is what we have as Hacker. Instead of Hacker is h4cker.org GitHub. It has numerous resources that links to their other tools and internationally vulnerable systems that can deploy in your lab. So again, please, this system that you use, that you are using, that you're telling everybody is the system that you have, don't expose it to these things. If you are going to do it offline, right? And that's why I always advise, download them, but run them on a system that is not usually on the internet, please. So if you are just getting started, the simplest way to practice your skill in a safe environment is to install Kali Linux or Parrot in a VM and set up Websploit Lab. So the process for setting up Websploit Lab can be found on websploit.org. Several of the examples covered later in this module and elsewhere in the course use the tools and intentionally vulnerable applications running in the lab, the Websploit Lab. Okay, so that's just like an insight into how to build it. So let's look at logic, understanding business logic flaws. Now, what exactly is that? Typically is understanding the structure of every interaction and then taking advantage of it, right? So that's typically what it is. So business logic flaw enables an attacker to use legitimate transaction and flows of an application in a way that results in a negative behavior outcome. So let's look at it this way. It's simply saying you want to have an interaction with somebody. Let's use the example of human beings. And you want to achieve a lot with the person. But if you attempt to go about it your way, you might have a challenge because the person has a way, the reason. So what you want to do to give the person a sense of autonomy or authority, right, or superiority over you, you study the person and go about achieving what you want to achieve in the person's way. Those of you who have children, somebody's asking a question. Let me see. So the recordings would be made available to everybody. It's not just you. One of the challenges we had, somebody's asking, I need the recording of this ethical hacking. Yes, the recordings will be available. And like I said, I'm taking my time to ensure that they are, what's it called now? Reputable communication happening in there because I know they will be referenced. I understand that we have a plethora of people who are here. Understandably, the number is depleting by the day, but hey, this content is going to be on the ISOC site or either ISOC or NCS site. And so they are going to be available. We had a challenge at the beginning when we started because that was the period where we have this power outage and also we kept having short recordings. It wasn't complete. Also, we had network issues. So some of them are actually broken. We've attempted merging them together to have a full session, but we're going to just post them like that. So you start seeing the links, I think, from tomorrow or thereabout. So Mr. Adeboale Taiwo. So the recordings the link will be dropped in the group. As long as you're in the group chat, you see the link there to the recording. So we're good. All right. So, so I was trying to explain about those of you who have, I was trying to explain about business logic flaw is more or less having to engage some form of, conversation with an application from a client or from a server in such a way that it appears legitimate, right? So there's a flow that each conversation, I said this at the beginning, right? And I keep repeating every now and then that interacting with a service requires certain conversations based on the rules that govern that particular service. So those rules are called protocols, and the protocols require some kind of traffic. Yesterday we handled HTTP, explained the different types of methods that HTTP uses, being one, get, post, put, delete, patch, head, connect, trace, options, and the rest of them, right? And all of these things are how do I put it? There are messages or methods that indicate the kind of interaction you want to have with the application. So usually we have different logic flow for different applications, right? So most common business logic problems are different from the typical security vulnerabilities in an application. Let me explain what that means. The attackers take advantage of, when we say business, remember that the conversation between the client and the server is a business. They are normally called transactions. So there's a flow that it should go, right? These conversations on an application can happen in such a way that it may result in negative behavior, right? Or a negative outcome. So taking advantage of that in itself, that's the business logic of every application. But the behavior which has been tampered with is now the flaw. So a challenge with business logic flaw is that they can't typically be found by using scanners or similar tools. I try to communicate in such a way that it may be passed smoothly. I know that it might irritate some people, but I think it helps me to ensure that I'm communicating the point. There are certain people that you say, let me counsel with them, and you can find the problem. But some people, their issues are so deep rooted that it is part of their behavior, that to the large degree, they don't even know that they have this challenge. So typically, every application, right, web applications are designed in such a way that they should keep track. We established that earlier. This track captures certain conversations that need to occur, which forms the session, right, of every interaction with a web application. This attack, right, is such that the logic, the flow of the conversation is taken advantage of, such that it appears as if it is part of the installation itself. So when you use tools or scanners, it won't report back like there's a problem here. So the likelihood of business logic flow flaws being exploited by a threat actor depends on many circumstances. However, such exploits can have serious consequences. So, one thing that is very important is data validation. Now, remember data validation, I mentioned that earlier, which usually, if there's data and whether it's data that is allowed for me to impute, right, or give out, there must be a way that I can verify that this data is considered valid. And for it to be considered valid, there must be an interaction with what we consider the valid one. So any entry or any capture of that data is compared against that valid one, which is normally in a database. Once we have a valid entry or an invalid entry interacting with a database, there are tendencies that it could actually corrupt the database in itself. So OWASP offers recommendation on how to test and protect against business logic attacks. Now, we have MITRE. MITRE is an association. Is a framework that allows for cybersecurity guys to, how do I put it now? Be able to compare. I think it's a framework. It's an organization, right? And their job, they do a lot of research, and this research are usually sponsored by people who have funds. Could be state sponsored or organization sponsored, right? But they themselves, MITRE is resident in the United States. And so most of their sponsorship comes from the government, right? And they are responsible for um, defense, cybersecurity, health, and what they consider critical infrastructure, right? So they do a lot of collaboration with various sectors, or let's call them industries, right? Various industries and academic organizations, and their focus is to attempt to address challenges that have to do with technology and policy, right? So they come up with documents, right, about a lot of things in cybersecurity. These documents are more or less like framework. So I dropped something in the group. Was it this morning or was it yesterday? I can't remember. Identifying framework, standards, and best practices. Please read it up. It helps to align what we are discussing. So they have quite a number of contributions that they've done, right? That's the MITRE guys now. I think MITRE is an acronym. I can't remember what it means anymore. I cannot remember, but is you cannot be in the field of cybersecurity and not have come across some of their um, framework, which is normally used, right? So this we're looking at it as this particular one here is what they've been able to do as regards business logic errors. Okay. So they've done a lot of stuff, quite a lot of them. They do a lot of collaboration, a lot of standards, they do a lot of cybersecurity and infrastructure, and initiative, a lot. The most common of them, I think, is attack. Attack is spelled ATT and CK, right? So overall, what they are known for is that they are very, very um, their presence is cannot be ignored in the cybersecurity field, especially in the United States. So we can eventually look at what's happening there, and perhaps since most of what they have is the framework, and see how we can, scale it down to what's happening within this. Because I want to believe that quite a number of you are perhaps here in decision-making places, and we can begin to look at what happens in our own sector. So this is a website. You can obtain detailed accounts of the common weakness enumeration, right? Typically listing what they consider are the weaknesses that occur or that can exist. So that the website also provides several granular examples of business logic flaws, include these are some of them: unverified ownership, authentication bypass using an alternate path, quite a lot of them, weak password recovery mechanism for password, forgotten password, incorrect ownership assignment, premature release of resource during expected lifetime. Somebody's asking a question. Okay, yeah, okay, Massachusetts. Thank you very much. So, okay, yeah, Massachusetts Institute of Technology Research and Engineering. Yeah, so that's their work. The ATT and CK is a very okay adversarial tactics, techniques, and common knowledge. Right. So, thank you very much, Bakel Gideon. Thank you. So, yeah, so that's who they are. So, what they do since and they are largely research-driven, research-based, technology research and engineering. So their focus is on cybersecurity. So improper enforcement of behavioral workflow and the rest of them. So these are some of the flaws. Now remember that we need to have ownership, right, of application or services, right? Web application. The challenge now is the fact that it's unverified. So that in itself is a flaw, right? How do I call it now? A situation where a developer or a particular application, right, has rights to certain assets, certain accounts, certain resources, right? Or let's say information generated, or we can say data generated by that particular um, things like, let's say, finance, right? Online transactions. These are things that are perhaps just, very available, but nobody can lay claim to it. But then, if somebody is also going ahead to lay claim to it, what are the parameters used to ensure that they belong to that person? So the document is quite exhaustive, and please try to look at it, right? It would help. Now, let's try to understand injection-based vulnerabilities. Apologies, like I had actually told us that I was going to be um, um, running through it. Right. Now, what is injection-based vulnerabilities or vulnerability? Vulnerability. Chai. English no easy. Oh. All right. So let's dive into it and see what happens. So part of testing a web application is checking for various weaknesses, which could be weaknesses that were not available or were not part of that particular application when it was built. However, it takes advantage of the transaction that needs to happen between that application and the client, and it injects a weakness into it, right? So a good place to look is any web page that accepts any form of credentials, gives you a form. If there's a place where you put form, that's why I always advise people, be very careful how you fill certain Google forms. They look like they are cool until you actually give certain people some information which they have. There's a lot of us here have filled lots of forms which perhaps we just shall filled it. We don't know which one is going to work. And then by doing that, we've actually submitted a lot of stuff to them, right? Now, any application that allows you to values, impute value, allow you to impute details like login credentials, things like contact us, response forms, right? Forum posts and the rest of them. Impute forms provide a way to get malicious codes into the system. What do you mean? What do you mean by that? We just sort of believe that if they have a website or if they have a page, then they are trusted. I can spend lots of money in building a very reputable looking website, all in the name of just, gathering as much information from me. What the attacker does is that he takes a code and injects it into the application itself. Remember that I said this injection vulnerability is not usually what exists with the application when it was developed. However, I also said this, that in interacting, using any service requires interaction with that particular service. And there are certain conversations that are exchanged, governed by certain rules or protocols. Those conversations usually are the part where an attacker can take advantage of to do that. Let me paint a very relatable picture. Typically in human life, if you hear a knock on your door, knock, 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 the natural response will be to go to the door and open it and then ask, who is that? Now, we've had a lot of attacks happen on account of that, that people have actually now modified how that works, right? So if you hear a knock on the door, you don't just open the door and ask, who is that? Because of certain attacks, right, which has led to low trust level, people go ahead to ask first, who is that? When you hear the person's voice, you hear perhaps a friendly voice, or you realize the person is not offensive, then it prompts you to go ahead to open it. And then some attacks happen on account of that. And then we retweak how we respond to doors, where people can actually have a small, keyhole or a particular magnifying eye, what's it called now? That stuff that I look through to be able to identify who is there. Apart from that, some people go ahead to look at a particular window to ensure the person standing there is alone. Then people go ahead again to attach, let's say, a camera at a distance so that when you hear a knock, even without having to answer, you go to your feed and identify who the person is. And sometimes it could just be a person who is a decoy. So you just let the person stay around there for a while and don't answer, act like you don't know. Now, these are part of human beings' ways of dealing with what is considered valid input. So the valid arrangement here, somebody knocks on your door, you open the door, right? Or somebody sends you a mail, you open the mail. Somebody, sends you a link, you click on the link. But because of the things that we've suffered over time, there's been a lot of education which tells people, hey, you know what? Don't just click on any link, regardless of who sent it. It could have actually been the fact that somebody compromised the guy's mail. Don't just download any video you see in a particular group. Somebody can just drop something in the group and say, ha, um, people in this group, maybe the people that have children above 16. Oh, there's a scholarship for people who are above 16 provided by XYZ organization. Please click on it, fill your children's name. Who knows? We don't know where this thing can work. Oh, you click on the link and then you've been able to open up and open because that link allows you to interact with a particular application, as it were. The input received could be malicious to you, or it could be that they are using that to extract information from you. So the attacker takes advantage of code injection. Now, what exactly is code injection? Now, it's simply adding a code into, um, let me try to put words that are um, just let's try to paint it in a way that is not too over our head because perhaps not everybody's into scripting, as it were. Now, the idea here is that a code would be considered series of scripts that activate or carry out a particular action. Now, if you are injecting that code into a particular environment, that's what the code is expected to do, right? So it in itself, code injection itself is a weakness, right? And how that happens is that somebody who has observed that particular place he wants to inject the code, right, would write a script, which is in this case a mal code or a malicious code. And then it's normally within an application. He inserts it, and usually these codes are executable. Executable means they can run themselves and it can be run by the system. What it does now is that it compromises whatever structure that application or the service has. And it can begin to steal things like, um, information, data generally, or it could even corrupt the system, right? Or completely just, of course, if it's corrupts the system, it compromises the system. Okay, so it just normally is a way of taking advantage of applications that were not properly built. Okay, and normally is with respect to points where you are expected to impute certain values for interaction with the service, which is like we said earlier, login credentials and all. So what the attacker does in this case is just creates that code and injects it into a vulnerable system to change how that system is going to carry out its function or force that application or a system to process information that are not supposed to be processed, invalid input. So once he's able to achieve that, which normally is the case, successful exploitation can lead to the disclosure of sensitive information, manipulation of data, denial of service conditions, and quite a lot more. So examples of all of these are SQL injection, HTML injection, command injection. Then there's also the LDAP injection weakness or vulnerability that we have. Okay. So let's take it one after the other. So SQL injection is I said that, I think I talked about that earlier. Perhaps went ahead of myself to explain some of those things. So SQL injection vulnerabilities can be catastrophic because they can allow an attacker to view your database, insert values into your database, delete some portions of your database, or even modify the records that are in your database. Now, in injection attack, the attacker inserts or injects not complete queries into the application. We're dealing with web application now. So it could be just, saying this is this. I don't know how to, well, basically imputing a value. And typically that application in its bid to validate that particular entry would compare that entry with a database. And usually these scripts or these injections are executable in themselves. So the attacker would now inject it into the command, sorry, the command into fields in an application or a URL in order to execute predefined commands. So these are things like select, update, delete. Now, this is for SQL. So you can see that these are the methods for SQL. As far as interacting with the database is concerned, these are the conversations that we should see. This is not the same with HTTP. Remember, HTTP, you have the get, post, and the rest of them. For SQL, these are SQL commands or statements. Select suggests that you want to obtain from a database, which is if you compare to HTTP, that is get. In get, you are retrieving. Update in this case is a command used to update database. If you look at that in HTTP, it is put, delete, similar, right? Insert into, used to insert a new data into database. In the case of, what's it called? In the case of HTTP, what you have is post. So there are quite a number of, so create database, alter database, create table, alter table, and all of this. So these are things they can actually add as part of what's going to interact with the database and thereby compromise it. So sometimes it could just be inserting a particular, imputing some things into the database and then making it exist. So sometimes you watch some movies, it looks very funny. Some people are going to, sneak into a place and they come at the door and they're telling her you're not on the list. It's like, please check the list. Don't be rude. Look at the list again. I'm on the list. They are buying time so that somebody can inject a particular value into the database that they have, which is what they use at the gate to check for who's supposed to enter. So typically SQL statements are divided into the following categories. There's the DDL, which is definition, data definition language. There's a DML, data manipulation language. There's transaction control statement, session control statements, system control statements, embedded SQL statements. Please look those up. Why are we looking at this? At the point of your doing some form of testing, you want to test all of these guys, test their structure, the interaction that they have. Remember that the language that exists for each service differ. And usually these attacks take advantage of the conversation that exists between the client initiating the request and the server itself. So this is an idea of this looking at okay, so let me see. All right, great. So we have here, this is an SQL statement. This is using try it editor, right? This is an SQL statement. And here it says select asterisk from customer where contact name like Savadra. So this is saying, I want you to go ahead to select from a list of customers, right? And look at the variable or the entry contact name. What I want you to look for is this, Savadra, right? So it goes ahead and extracts that guy and brings it out. So this is selecting now. With this particular SQL statement, it will run the SQL against the database, the entry now, this is the statement against the database, and come up with what you queried it to bring up to bring. Okay? All right. So let's look at it. Yeah. So the statement shown in figure 6.7, that's the figure we just saw, is a select statement that is querying records in a database called customers, and that specifically searches for any instances that match Savadra in the contact name column field. A single record is what is displayed. Now, this is not shown in a web form. Okay, this is what you have. Of course, this is what we're looking at as a command. This is what was added. Select from customer where contact name and that. So web applications construct SQL statements, and these statements are usually what involve certain SQL syntax that are invoked by the application mixed with some other data that is supplied. The first portion of an SQL statement is what we see in, let me see, is in this, yeah, this 6.8, no, this 6.8. Yeah, so this is the first portion of it. Select, right? So the first portion as shown, typically the application sends this portion to the database behind the scenes. The second portion of the SQL statement is typically user input in a web form, right? And if an application does not sanitize user inputs, an attacker can supply crafted input into an attempt to make the original SQL statement execute further actions in the database. SQL statements can be accomplished using user-supplied strings or numeric input, like this, something like this. When this string is entered, Smith or 1 is equal to 1 is entered in a web form, it causes the application to display all records in the database table to the attacker. So I'm looking for Smith, right? This means 1 is true. When these two statements are true, it's going to go ahead and display every detail of any record like Smith, right? So look at this, for example. This is WebGoat, it's an application, example of a basic SQL injection attack using string-based user input. So in this case, let me try to see what's here. Yeah, so the attacker is using numeric input in this case. Yep. And so we see that here. So here it is Smith, right? Or 1 equals to 1, get account info. Then we have all of this. You have succeeded in displaying all of this information here. So the action is to download WebGoat or run WebSploit Labs and then look at certain exercises in the SQL injection practice lab. Okay, so it will display most of this. So this is just to be able to find the weaknesses that exist inside the database. So figure 6 to 10, 610 shows another SQL injection attack example. In this case, the attacker is using numeric inputs. Here is 0. So this is the login. User ID is 0 or 1 equals to 1. So this is just querying a database. So putting invalid input. So one of the first steps when you find SQL injection vulnerabilities is to understand when the application is interacting with a database. This is typically done with a web authentication form, search engines, and interactive sites such as any e-commerce site. You can make a list of all input values whose value could be used in crafting a valid query for SQL. And it includes trying to identify and manipulate hidden fields of post. Remember what your post is. Post is, like I said earlier, based on what we're looking at, is to impute the value. Requesting that testing them separately, trying to interfere with the query and to generate an error. As part of penetration testing, you should pay attention to HTTP headers and cookies. So these are things you should identify. Things like single quote, semicolon, right? That are added to any web parameter. They are usually how do I put it now? An attempt to, these are strings, an attempt to impute or to get values from a particular database. You can use comment delimiters, things like um, here, double dash or slash asterisk asterisk slash, as well as other SQL keywords. So for people who are into building web pages or into databases, for example, these um, delimiters make sense. Keywords like and or, these are operands or operators. Another simple test is to insert a string where a number is expected. So if you insert a string and there's a number, you're simply suggesting every other value, right, within the array of numbers be displayed. And so these are usually a way that people actually get this information from a database. So let's look at SQL injection categories. There's in-band SQL, out-of-band, and then there's blind. So in-band, these are the categories that these SQL injection attacks can actually come. In-band, this is the type of injection where the attacker obtains the data by using the same channel that is used to inject the SQL code. So it's within the same band. Out of band is where, of course, the attacker retrieves data using a different channel. Say maybe an email, a text, or let's say chat, message, instant message, Telegram, WhatsApp. A lot of it happens on Telegram these days. Telegram is not so sanitized as much as it actually allows you to send quite a large amount of traffic. It's actually not as sanitized as WhatsApp. A matter of fact, those two self are not as safe. So we have things like Signal. There's another one, forgotten the name. I saw it the other day. Signal and forgotten that one. So these ones could be used to send attacker with the result of the query, or the attacker might be able to send the compromised data to another system or another person. So that's why most of those guys drop information in certain groups and before you know what's happening, before you know what's happening, they would have gone far. Then there's blind or what we call inferential. In this type of injection, the attacker does not make the application display or transfer any data. Rather, the attacker is able to reconstruct whatever information it has intercepted, right? And to send specific statements and then be able to discern the behavior of the application and database. So typically, I know that these are all part of the logic flow flaws. I understand that an application is interacting with the service or a client is interacting with the service or the web application. And these are the kind of things that they converse. So I'll just mimic and attempt to get them to submit. So there are essentially 5 techniques that can be used to exploit SQL injection vulnerabilities. There's union operator. This is typically used when an SQL injection vulnerability allows a select statement to be combined with more than one query, right? There's Boolean. This is used to verify whether this is true or false. So it's either 0 or 1, on or off. Error-based technique. This is used to force the database to generate an error in order to enhance and refine an attack injection. Simply saying, I know that perhaps, or maybe I don't know. I just realized that there's an application interacting with this, there's a user interacting with this particular application on a service. Now, I don't know what their pattern of response is, so I'll just impute whatever value with the hope that it's going to generate an error. The error gives an idea of what is expected. Then I can go ahead and refine tune until I get that. So there's out-of-band technique. This is used to obtain records from the database by using a different channel. For example, it is possible to make a HTTP connection, send the result to a different web server or a local machine running a web service. So you just redirect them. And there's time delay. It is possible to use database commands to delay answers. An attacker may use this technique when he or she doesn't get output or error message from the application. Just delay it. That way also, legitimate users find it very hard, tough interacting with the device. Okay, so let's go on to look at how SQL injection can be manipulated, right? So SQL injection can also be exploited by manipulating a URL query string as demonstrated here. So let's try to see what this means. So there's a HTTPS :store.hacker.org/buy stuff.php with the ID 99 and one equals, so this is a Boolean, right? So this particular, the vulnerable application then performs the following SQL query. This is what it does. So it will select from, now because it's going to select from products, because it's going to store from products, right? It will select product, sorry, from product ID is equal to 99, and it should either be 1 or 2. So the attacker may send a message specifying that there is no content available or a blank page. The attacker then sends a valid query because now it now knows the structure of this. The attacker can then send a query to see if there are any results coming back from the application as shown here. So this is this. Give me 1 of 1. So this is go to the store. This is this particular store. Buy stuff. Session ID of 99. This is session ID. And 1 equals 1. Some web application framework allow multiple queries at once. An attacker can take advantage of that capability to perform additional exploits, such as adding records. So we have this particular entry here. So the following statement, for example, as a new user called Omar to the users table of the database. So now, note, I'm going to interact with a database here. So by this command, I'm going to the database, right? And this is what I'm going to, so there is insert into. This is what the script or the person who drafted the script has added. So it's going to be inserting into users, right? And sorry, let's go back. Insert into users, a username, and the value that you should insert into that place is Omar. So now I've added a username, which means that I can actually query the database to provide my Omar, right? So let's look at, let me see what time it is. Okay, so great, we have a good time. So we'll cover quite a number of stuff. It's going to be very bulky. Now, database fingerprinting, right? What exactly is database fingerprinting? No, typically when you fingerprint physically, of course, it simply has to check with with a storage somewhere and verify whether that fingerprint that you've added is something that is considered valid. So with weaknesses, right, in order to successfully execute complex queries and exploit this, we need to look at what this is. This is just a technique that is used by a lot of these threat actors, right, to be able to gather information about the system of database that you have. Things like the type of database that you have, the version of the database that you're running, the structure or the details as regarding the configurations that are there. And why the attacker needs it is because the information he gathers from there can be used to further exploit the system. So what does it do? It just looks for the fingerprinting of that particular sequential, the query language, right, the SQL. So in order to successfully execute complex queries and exploit different combination of SQL injection, you must first fingerprint the database. And the idea here is look at the database and find out what you have there. It's like extracting the structure of that database. So the SQL language is defined in an ISO document, a standard ISO IEC of 9075 standard. So databases differ from one another in terms of their ability to perform additional commands, their use of function to be able to retrieve data, and quite a number of features. But this is the standard. So when performing some advanced SQL injection attack, an attacker needs to know what is happening at the database, which is not in your front, is at the back end, right? So what you want to find out is what type of application was used to build a database. Is it Oracle database? Is it Maria database? Is it my SQL database? Is it Postgre database or SQL? One of the easiest way to fingerprint a database is to pay close attention to any errors returned by the application, as demonstrated in the following syntax error here. This is the syntax error. It's just saying my SQL error. So I now know that this guy is running SQL, right? So let's put it this way. You know, sometimes when somebody is talking with you, right, the person doesn't know jack. The person is attempting to find details of what you think you know. And the person might be raking and telling you this, that. But I think we mentioned that at the beginning, just a way of being able to extract what we consider valid information. Somebody can tell you, you don't know it. I know it, I know it. By trying to correct what the person has said, say, no, what the person has said is wrong. Some people can intentionally tell you wrong stuff because they want to be able to just extract from you a query that says what you have said is wrong. You know, I think I said in one of the first class where somebody can be raking and said, do you know this guy? I say, no, you don't know him. The guy's name is Jibril. Now lie. The guy name be Jibril. His name is Asha. And he lives here. He shot his next door to my house. He has two cars. That's the guy that was not day before yesterday. His son celebrated birthday. You gave an error in trying to respond back, telling you that what you submitted is an error. I think we talked about in social engineering. Yeah, right. And the person now responds with details that you didn't bargain for. But in the person's response, which is the bit to tell you that what you've entered is an error, person submits to you a lot of other details that you know. So, moral of the story, if the person who is talking is saying wrong stuff, if it's somebody who you are close to, bonam, just they go where they go. Right? So here's an error. And this is showing that it's from Microsoft SQL database. So it responds Microsoft SQL native client error. This simply shows that it's from Microsoft. Following is an error message from Microsoft SQL Server database with active server page, error, server error in application. And this one is from Oracle. It's Aura 00933. Command not properly ended. So typically copying this and checking it to tell you that this is actually a code that is displayed usually when an Oracle database receives a command that was not properly completed. And then here, this is from Postgre database. It's PSQLE exception. This is usually an error that is generated once there is an unterminated quote string at or near a particular caret. These indicators will be indicated telling you where that happened. Or it could be this query failed, error syntax, error at or near this, right? So these are like ways that people, the attacker actually test the database to find out what language. And the reason why they want to do this, once they know the language, or sorry, they know the structure of the database itself, the service, they're able to now script properly targeting the specific database. Okay, if you're trying to fingerprint a database and there is no error message from the database, you can try using consternation as shown here. My SQL, code finger plus printing, that's for my SQL. And there's SQL Server, there's Oracle, then there's Postgres. All of them are like this. So these commands would help. So the union exploitation technique, this is where the operator is used to combine results of sets of two or more select statements. For example, here, select zip code from this, union select zip code from this, from suppliers. So we have zip code from customers and suppliers. So by default, the union operator selects only distinct values. The distinct values here are zip code from what we've indicated here. You can use the union all operator if you can, if you want to allow duplicate values. So attacker may use the union operator on SQL injection attack to join queries. I think it's like a repeat of what just, no, it's not a repeat. So the main goal of this strategy is to be able to obtain the values of columns that is more than one in other tables. So like we saw here, it is looking at values from customer and suppliers. And what we're looking for is their zip code, right? We're in Hacker, right? These are the people, these are the database of a particular table, maybe it's Hacker customers and then Hacker suppliers. So as shown in this particular example, using a union operand in the WebGoat vulnerability application to simulate an SQL injection attack, the example shows the following string in the web form. Omar, union select one, user underscore name, password, right, from all of this. So this is what was entered here. So here it says, though through experimentation, you found that this field is susceptible to SQL injection. Now you want to use the knowledge to get the content of the other table. The table you want to pull data from is this. This is the table, right? So you create a table. So what you're looking for is user ID, right? Not full primary key. User name here is Vakar12. Password is that. Cookies for this particular guy. So everything we're looking for is for this particular, is it Vachar and I've been a Vakar, right? So hit enter, then this guy goes ahead, retrieve all data from the table as relates to this query that is made. So what is Dave's password? In this case, here, so you have succeeded. So user ID, first name, last name, is a number, type, cookie, login count. So Dave's password, this is some guy's password, Jeff. So well done. Can you also figure out a solution by appending a new SQL statement? So this is WebGoat. Please download it. I think I mentioned it earlier. That is a tool that you need to use as part of the practice. I wish we could have a physical time, but of course this doesn't allow for it. Hopefully sometime in the future we can have our own time. So let's get out of bound exploitation. No, Boolean, sorry. Boolean exploitation. So the Boolean technique is used in blind SQL injection attack. In blind SQL injection vulnerabilities, the vulnerable application typically does not return an SQL error, but it could return a HTTP 500 message. Remember what our message is? A 404 message or a redirect. 404 is error. 500 is server-side error. Yes, somebody's asking a question. At the end of the class. So yes, we're going to have those tools. Okay, the tools that I talked about just now in Build Your Lab. Is that the tool you're talking about? Okay, or the tool I said you should download. Okay. I think I know. I get what you're trying to say. The things that we need to download, right? Okay, yes, I'll do that. All the tools. Which all the tools are? Which of all the tools? Is it what you need? Okay, that you need to download. Ah, okay. So would you allow me the benefit of compiling them and dropping in the group? JB? Ah, sure. Thanks. So I'll look at that and, well, if you have access to the curriculum itself, at the end of each of your, uh, how do I put it now, topic, for each activity we're discussing, there are actually tools listed there because it'll be listed, download this tool, download that tool, and so on. Like, I think at the end of this particular section, understanding injection-based vulnerability, there is a lab. The lab focuses on injection attack. So there is a specific tool that is indicated there. I think that is at understanding injection-based vulnerability, I think it's 6.4. At the end of that, there's a lab, right, which captures injection attacks, and that will be able to help explain what needs to be done. So we're dealing with injection vulnerabilities. I also, again, wouldn't want to spend too much time on it. Okay, but typically an error could actually return telling you it's the server end side or it could just be client side. Remember, 400 is client, 200 is success, 400 is error from client, 500 is error from, that's a HTTP error now. We talked about those yesterday. So let's look at this Boolean injection attack. So this is a tool. This tool is a, what tool is this? This is a, let me see. What tool is this? This is, sorry, let me get that. Anyway, like I said, this is DVWA. I'll find that tool. Okay, yeah. Using the intentionally vulnerable DVWA application. Yeah, DVWA is what it is here, an injection blind. So again, like I said at the beginning, these are tools. And you can just get swarmed with these tools and not know what to do with. So one of the easiest way to approach this is to read the curriculum, go through some of the modules, right? And there are just 10 modules. So if you dedicate a day to a module, you'll achieve a lot. In 10 days, you'd have been able to do that. Okay. So 10 days might not be consecutive days. So out-of-band exploitation technique is very useful when you are exploiting a blind SQL injection vulnerability. You can use database management system, DBMS, to execute an out-of-band connection to be able to obtain the result of the blind attack. So this is, the server is in malicious.hacker.org. Please note that most of these sites are already, how do I put that now? They are built for this course, so they are not dangerous. So you can try them on your device. So this is blind SQL, sorry, out of band SQL injection vulnerability. In this case, this is the client who's supposed to be interacting with the server. So this guy wants to move you here. So he exploits the blind SQL injection vulnerability out of band. This is where he wants attack. So the band that is going to be attacked is not where the attack is sent. So he sends it here, and the victim sends the result to a different server. So this is the store. Typically, maybe this is where people come to buy stuff. Happens a lot. So Jumia, Gigi, most of those sites that you go to, be very careful the kind of links that you click on. So this is an example of an out of band attack. You could actually go there, do some stuff, but the attack is happening on another place. Let's go straight to stacked queries. I'll let you read that. I want to dive into, okay, so let me deal with that. So in a normal SQL query, you can use a semicolon to specify that the end of a statement has been reached, and what follows is a new statement. That technique is used to execute multiple statements in the same call to the database, right? So the query is stacked, which is not union now. Union queries is used in Excel injection attacks are limited to select statement, whereas the stack allows you to be able to execute any SQL statement or procedure together. So a typical attack using this technique could specify a malicious input statement such as this: delete from customer. So like in this case now here, so it's select from customer where customer ID is 1, then delete that particular entry from the customer. right? So this is the semicolon, remember? So this is how you know the stack. So stack, this is our queries. So go to the a list of customers, right? So from customer, where there's customer ID equals to 1 equals true, delete from that list of customer that one that you find to delete that guy. Now, when trying to exploit the blind SQL injection, the Boolean technique is very helpful. Another trick is to also induce a delay in the response, which indicates that the result of the query, of the conditional query, is true. The time delay technique varies from one database to the other, depending on which MySQL or the rest of them that we talked about. So this is from MySQL. Time delay technique here says, HTTP, this is the site, this is the link. Of course, you're going to buy, right? ID is equal to 8. And if the version is like 8%, sleep, right? In this example, the query checks whether the MySQL version is 8, right? 8x the version, then forces the server to delay the answer by 10 seconds. So Siam, so if it is like 8, this is the version. If, for example, you go to that site and you're going to buy, right, session ID is 8. When you get there, if you once you realize if the version on that particular side is version like 8, then this device should sleep for 10 seconds. The attacker then increases the delay time and monitors the responses. The attacker could even set the sleep parameter to a high value since it is not necessary to wait that long, and then just cancel the request after a few seconds. So what are these attacks intended for? Remember, this is simply manipulating database. Why? There's some information I want to get from there, or I want to also impute certain information so that I can compromise or redirect people who hit that particular site somewhere. Okay. Surveying a stored procedure SQL injection. Now, a stored procedure is one or more SQL statement or a reference to an SQL server. Stored procedures can accept input parameters and return multiple values in the form of output parameters for the calling program, meaning that typically interacting with a database requires that you impute certain values, which will be used to check against the database. So what will happen here is whatever value, right? Because it is a store, the procedure here is to identify that I can accept as many of these parameters, right? And then return as many output, right? Depending on who is actually intending to interact with the database. They can also contain programming statements. That's where the challenge is. And this programming statement usually executes operations in the database. And it could be just initiating certain procedures, which is like, let's say, impute, delete, and all of those. If an SQL server does not sanitize input, it is possible to enter a code that is malicious and it can be executed within the allowance for the store. So the following example illustrates the concept of a stored procedure. Create procedure for a user login whose username is varchar 20, right? The password is varchar as declare this. Set that string, sequence string, to equal select one from user where username is plus username and password. Now, by entering this, where are we now? By entering Omar or 1 equal to 1, some password in a vulnerable application where the input is not sanitized, an attacker could obtain the password as well as other sensitive information from the database. This is an error. It's not supposed to be Omar. This is virtual here. So by doing this now, I can go ahead and create and then extract the valuable information. Say, for example, username and password of the particular user I've identified. So there is a tool called SQL Map. So JB, this is one of the tools, SQL Map. It comes pre-installed on Kali by default and also on Parrot. Or you can go ahead and download it from https sqlmap.org and install it on any compatible Linux system. Ubuntu, Linux, and the rest of them. Yes. Yeah, thank you. All right, let's dive in. So how to mitigate against SQL injection? I said something at the beginning about input validation. It's an important part of mitigating SQL. So typically, we've been able to identify so far that part of the challenges that are faced in SQL or what we know as SQL injection, is usually as a result of values that are imputed, because interacting with the database require that you compare whatever entry has been entered into a pot, into a space, and validate it against the database, which usually allows interaction with the database. And based on whatever input has been added, right, if we do not sanitize or filter what inputs are allowed, right? Some sites, I remember that once you begin to type some things and you put underscore or put parentheses, they just don't allow it, because in itself, they identify that there will be a database that should be checked. And these values are usually um, special characters that could initiate certain strings. No, sorry. These are special characters, including strings, that could initiate certain actions against the database. So the best mitigation for SQL injection vulnerabilities is to use immutable queries, such as the following. Immutable queries are queries that are not argue that you cannot is it argue now? Yeah. Right. So things like static queries, database, static queries, parameterized queries, stored procedures if they do not generate dynamic SQL. So the idea here is to um, use immutable queries, which is more or less information that um, cannot be how do I put it now? That cannot be modified, right? Or they cannot. They're usually read no, yeah. They're usually information. Trying to remember my so that I don't submit something wrong. Immutable queries are queries that do not interact. They are purely read only. They are structured in such a way that they're supposed to retrieve and view data without making any changes to the data. That's immutable. I think I got that right. Right. So, but it just is a way to be able to ensure that in interacting with the database, there is um, nothing can be altered. Yeah, that's just what it means. Nothing can be altered when interacting with the database. So immutable queries do not contain data that could be interpreted. In some cases, they process the data as a single entity that is bound to a column without interpretation. So following are two examples of static queries. Select from contact. Select from users where user is equal to Omar. So it's not just looking at other things where it's able to check with database. So the following are examples of parameterized queries. String queries equal to select from where the name is equal to this. So it's a prepared statement. And the idea is just to select from this. If this is equal to this, then this. Otherwise, just shut down. Okay. And command injection is another vulnerability we're looking at. It's an attack in which an attacker tries to execute commands that he or she is not supposed to be able to execute on the system via a vulnerable application. Command injection attacks are possible when an application does not validate data supplied by the user. For example, data entered in web form, data stored in cookies, data that contain HTTP headers, and maybe other elements. The vulnerable system passes that data into a system shell, and then the command injection happens when an attacker tries to send operating system commands so that the application can attempt granting them privileges of the vulnerable application. So command injection is not the same as code execution. Code execution is where a request requires that the shell, right, goes ahead to activate a certain behavior. Okay, this is usually what happens for those of us that use proprietary operating systems, where you are not using command line to initiate certain stuff. You just click. That click has embedded behind it a string of execution code, which once you double click or right click based on what is written behind it, that action is carried out. Whereas command injection is just attempting to send commands that it wants to trick the operating system into initiating certain behaviors that would compromise the system. So command injection against web application is not as popular as it used to be because modern application frameworks have better defenses against these attacks. Okay, so we have, this is from DVWA, right? So this is another application here, DVWA, right? And in this figure, the website allows the user to enter an IP address to perform a ping test to that IP address. So here's the ping test. So I'm attempting to ping this particular, right? So I say ping this address and show me the content of the etc password. And it goes ahead and pings the site, comes back and comes out with information, right? And then here we have all of the details regarding the login, the cache, all of the systems, right? So LDAP injection, that's lightweight directory access protocol, has its own attack, which is the LDAP injection. The vulnerabilities are input validation vulnerabilities. Again, if you observe in the conversations we've had so far regarding this web application, and we're looking at injection-based vulnerabilities. And this is cut across a lot of all of these services that are available. The services actually keep a database, and of course, naturally, one way to be able to ensure that the person who is using a particular application or the person who is using it is the person who should use it is by authenticating the user or that particular person, and then also giving some form of authorization. Now, in doing that, the person requesting the service must impute certain values, which you must compare to a pre-stored database and be able to now validate that this person is here and the person has so and so level of authorization. And typically, since we know the database is the point where you check and allow certain access to some services, as an attacker, I want to poison that database. That's what we're looking at here. That's why we call it injection. So it is actually inserted into it where code or scripts are written and forced to, interact with the database, which typically occurs because each time an entry is added to a particular input entry slot or opening, there's a need to validate that input. That input would be against the database. And sometimes there's no limits to the kind of things that are allowed there, which we've talked about so far. It is important that whoever is building an application or building the database, it restricts certain values to not be allowed to enter into the place. And once you do that, this is not allowed, should be an output that comes into place. So for LDAP, injection vulnerabilities is where the attacker uses some vulnerabilities to inject and execute queries to the LDAP server. Now, a successful LDAP injection attack can allow an attacker to obtain valuable information. This is typically what we're talking about earlier. So, what is exactly the LDAP? How do I put it now? Um, LDAP procedure to be able to be sure, so that we can look at why this attack actually happens. Typically, a server, right, that um, has database for the purpose of granting access and managing accesses and the access, and also managing interaction with services over the network, right, is what LDAP actually contains. So typically, we're looking at things like access control, or let's put it this way, start with authentication. Then there's access control, right? And then we'll have things like, let's say, authorization. No, okay, no. Authentication leading to access control, and then authorization, things like that. I don't know whether it's in the right word, but typically that's what LDAP attempts to do. So it focuses on a particular environment, right, where you have sort of like either captive portal or let's say like an active directory, which is a directory that captures people within a specific area. So generally, right, LDAP is a server, and it first one needs to ensure that there's a connection established with the client who is attempting to access the services, and then goes ahead to make certain ports available for that particular service to go ahead to interact. So there must be authentication, right? There must be authorization, and all of these things lead to accessing the data. So typically the attacker, or not the data, the service, the attacker attempts knowing that he may not be personally listed in that database, and so authorization and approval will be tough. So it goes ahead to insert or inject values that will compromise the way the LDAP looks at the request is making. So once it is successful, a successful LDAP injection attack would allow an attacker to now interact with the database and also obtain valuable information which it would use for further attacks, like perhaps be able to extract people's usernames and perhaps their credentials. So LDAP is an open application protocol that many organizations use to access and maintain directory services in a network. It's defined in RFC. I talked about RFC yesterday. RFC is actually a document or like a collection of conversation happening within a particular community. And these communities submit their own findings about a particular service. They query it and then conclude on what needs to happen. Then they release the document, which is, of course, revised as time goes by. So RFC is referred to as a request for comment. So the one that handles LDAP is 4511. So similar to SQL injection and other injection attacks, LDAP injection attacks leverage vulnerabilities that occur when an application inserts, remember, we talked about input validation. What begins to happen for LDAP now is that there's an unsanitized user input. What it means is that an input that is not validated. How do we mean? Every of these databases have like a library or a dictionary of what they consider valid. Why? There are certain scripts or certain strings that can actually contribute to influencing how how the application database operates. So those ones should be issued by a particular account who is authorized. Any other account should not allow such input. So typically, any input that is inserted, right, and it is unsanitized, inferring that it is usually what is not validated, right, can actually influence the behavior of the database. So by sending crafted LDAP packets, attackers can cause the LDAP server to execute a variety of queries and other LDAP statements. Why do they want to insert these queries? Well, they want to access your database and to be able to see what you have stored in your database and thereby mimic what is stored in there to be able to gain access. Because, for example, in the case of LDAP injection vulnerability, it could allow an attacker to modify the tree and modify business critical information, thereby allowing some form of interaction that can compromise the network. So, two ways and these attacks can happen is to be able to bypass authentication. Remember that there must be authentication. This is where the injection allows this particular guy to use credentials that have been, it just avoids having credentials checked. And these things happen to human beings as well. You can see some people just entering a certain door, passing, greeting everybody, but there's some other people who are entering. If you go to the airport, you see it happening a lot. Some people, maybe because they've actually given those people some gunja before, they just allow them pass. There's some case that happened some weeks ago where some lady had her passport seized because she wasn't going to give 5,000 naira for load. And the story was changed, based on what was in the news that she was carrying stuff from the abroad into the country and blah, blah, blah. I don't know how they concluded the information. So one is to bypass authentication. Of course, if somebody is bypassing authentication, suggestion is that the person is not there for good stuff. So information disclosure is another. This is where an attacker injects crafted LDAP packets to list all resources that are available in the organization's directory. Thereby, and by doing this, is just performing one of the first steps to penetration testing, which is reconnaissance, gathering intelligence, right? Just be able to go around and gather information. So there's a lab on injection attack, and it's how to exploit SQL injection using DVWA. That's one of the applications download, JB. DVWA. I think the link is somewhere. I'll find it and drop it in the group. DVWA. I don't know. I don't think then you have to do a research on SQL injection mitigation. So this is just using Google or any of those tools to just search and find out what are the ways that are, yeah, okay, great. Thanks, JV. One of the ways that can actually mitigate SQL injection. So let's go to the concluding part of today. As it stands, unfortunately, we will not complete all. The rest of it will actually be what you'd have to work with or do. So next, we're looking at exploiting authentication-based vulnerabilities. Again, this is not different from what we've actually talked about, but then taking it one after the other. We're simply looking at their authentication that needs to happen, right, for users to have access to certain services in your network, right? But however, we'll take advantage of that authentication and see how certain weaknesses in there can be exploited and taken advantage of, explored and taken advantage of. So an attacker can bypass authentication in vulnerable systems by using several methods. One is credential brute forcing. Two, session hijacking. Three, redirecting. Four, exploiting default credentials. We advise people, whatever, like, I just want to jump into this because a great number of people actually stick to default and the things like admin, right? So those ones uh they're very dangerous. Okay. Then we have exploiting weak credentials, then exploiting Kerberos. We talked about Kerberos earlier. Let me, I don't know if I have it listed here. Just jumped into session hijacking. Before I do that, let me attempt to explain what credential brute forcing is like. Let me attempt to explain it. So, this usually is where the threat actor, right, which is otherwise known as the attacker, attempts to gain access to a system or possibly does a combination of username, right, and passwords. That means the person has like a database or like a collection, right? And usually this is not done manually. Okay. So it's usually done through automated means, a particular application or a script that runs all of this. Okay. So typically you can target a particular person. First of all, be able to identify first, typically, let's say it will target, let's say maybe an application, a website, or a particular login portal, right? Or a system that you're expected to perhaps log in with certain credentials. Okay. So you can picture things like, let's say, SSH sessions. SSH is secure shell. And typically, SSH actually is domiciled on a particular device, and it depends on the kind of system that is deployed for SSH. The database that's going to be used for authentication could be local, meaning it is actually created on the device on which you're logging into, which in which case it will check the database that is installed locally. Or it could have the option of referring to another server somewhere that keeps the details, right? So either which way, there's going to be some form of brute, very brutal approach at arriving at who possibly could be the username that will allow me access into this place. Of course, it will prompt you with a password prompt. And at that point, again, there'll be another brute attempt or brutal attempt at at guessing what the password is like. So you target a service or a system or an application. Perhaps attempt to log in. You can use there's an application that I downloaded the other day. I was trying to find it. The name just jumped into my head now. It's called Burp, Burpe. The Burp, Burp Suite. There are two versions of it. Um, JB, that's another tool. Burp, Burp is a suite. We have the community version and then the professional version. You are limited in the community version because, of course, is normally what is allowed for everybody to use. It's like popular side and what's it called? It's like economy. It's like economy and business class, right? Okay, nice. Okay, great, great, cool. So those tools that can be used for brute forcing, right? Where you automate how do I put it now? Where you automate attempts to, guess usernames and passwords. You can actually put a range and use that. So let's go straight into session hijacking, which is part of what the curriculum covers here. So a web session is a sequence of HTTP request and response transaction within somebody that's considered a client and a web server. And we established this yesterday that if you say somebody is a client, is simply a a device, right, that has configured or installed on it the client side of the conversation. So this is the one making the request. So it could be anything, a wristwatch, a phone, a door, as long as it has the capabilities. So these are the process. So whatever happens between the two of them, this is usually what should occur. There's first of all the pre-authentication, right? Typically, the conversation that need to happen, right, before authentication, like gaining attention of that server or service. Then the next thing is to impute certain values which must be checked to validate that this user account exists. And that's where authentication comes in. Now, once authentication comes in, most times authentication comes with some level of authorization or not. Okay. But once authentication is completed and is successful, then a session begins between the client and the server. That session would need to now be granted some privileges. This is why I said authentication could come with authorization or not, is because after session management starts, now the session is active. The next thing is to identify what authorization that client has to the server. Is it getting? Is it putting? Is it posting? Is it deleting? Is it patching? As the case may be, depending on what service. Is it perhaps tracing? Right? All of these services. So that's where the access control comes with regards to what this user who's been authenticated has privileges to access. And then if we are done with that particular session, then there's a session finalization, which indicates a reset or a finish to that connection, in which case the server terminates and they all go ahead to synchronize this terminate request and then finalize it and end that session. Now, remember we mentioned at the beginning that for each interaction that needs to occur between the client and the server, there needs to be some form of credentials or some form of information that is kept while a session is active, right? Remember, the session has to have an identity which is managed. There are a series of transactions that occur between the client and the web server, which must be maintained. All of them are put into what's called the session, right? Now, in that session, there are conversations that are kept. These conversations indicate certain preferences. We talked about that at the beginning. Preferences would be perhaps the language, the theme, or the different, so that once that particular previously authenticated user account or client accesses the same service on the server, you can just bring up the last conversation that occurred with that particular client, except of course you want to change it and all. So it's very, very important. So now, how do these sessions get hijacked? A large number of web applications keep track of information about each user for the duration of the web transaction. Several web applications can establish variables such as access rights and localization settings. These variables apply to each and every interaction a user has with the web application for the duration of the session. Now, there's an example which we have, I think it's from Wireshark. Yep, we're going to get there very shortly. Now, these variables, for example, in the figure we're going to look at later, Wireshark being used to collect, it shows Wireshark being used to collect the packet capture of a web session to CNN.com. You can see the different elements of web request, which is get, right? You can also see localization information, in this case, Raleigh, New York City, in a cookie. So let's look at this. Now, this is a capture of Wireshark. And for some reason, okay, this is the client, this is the source, that is this is the server. This is the client, right? And this is the HTTP requests. And okay, let me just focus on what's here. For example, here, these are the two that are highlighted. So we see for this particular transmission control protocol, it indicates the source port to be 80. That is why I know that this is the server. So it's the HTTP from the server. And then the destination port is 5514. We talked about that yesterday, how the port numbers are very important for communications across the internet or across the network. There are certain services that are considered well known. These services are usually very popular services, and they range from services that we use every day, every now and then. Now, typically, a source or a client who is indicating, who is initiating connection with the source, with the destination, we have to generate a port number. And we also mentioned yesterday that the combination of the IP address and the port number forms what we call a socket. So we can see here it says that source port is 80. That's coming from the web into the destination port, which is 50512. So these port numbers are divided into three: well-known, registered, and dynamic. The dynamic port numbers are generated by users, right? So we observe here that if you identify this particular flag, right-click on it and see TCP stream, right? If you follow the TCP stream of this particular conversation, here we notice that it indicates that this was a GET request, right? And is using a HTTP version 1.1. The host who is doing this response is www.cnn.com. The user agent, which is the client who's attempting accessing that site, is using a web browser. So I learned that typically most of the web browsers, right, have the same structure. So they could be different names. but this is from a Linux system, right? Linux system. And it was accepted. This is the page that's been displayed. It is an application, HTML. The page is being displayed to this guy. So these are the cookies. This cookie indicates that the country code here is United States, right? And the person, right, is in Raleigh, New York City, US, that. Is that New York City? I don't know what NC is. Now make a no form size, I'll be US. Okay. If it be NC New York, Raleigh is in New York City, right? So so this is the server's end. So this is from the client, this is the server's end. Server vanish, retry after 0. This so it has ended. Okay, yeah, I think I understand what it's saying. Where was it? Said something about okay, it was captured. I saw that. Okay, here, nice. Here, this particular one indicates finish, right? And acknowledge. So here, that particular session is over, right? Retry after this number of seconds. The cache is this, location is cnn.com. This is what it accepts. So following the TCP screen, we're able to tell that this particular website, right, that the person attempts reaching is in cnn.com, right? The web capture from this. Now, as you learned earlier in this module, applications can create sessions to keep track of users before and after authentication. So here, this session is kept. This session is active, right? Now, once an authenticated session has been established, the session ID, or what we refer to as a token, is temporarily equivalent to what is used as its strongest authentication method by that application. So things like username and password, or any other things like, let's say, digital certificates based on the client and so on, are kept. In order to keep the authenticated state and track users' progress, applications provide users with the session ID. This token is assigned to session creation time and is shared and exchanged by the user and the web application. And like we said earlier, that is what is called a session. The series of those IDs put together and the conversation at the core can be tied to that particular session ID. The session ID is a name and value pair. There are multiple mechanisms available in HTTP to maintain session state within web applications, such as cookies. We'll establish what that is. Cookies are like um, um, typical what we just talked about now as per keeping track of conversation is actually the cookies. That's why sometimes if your device is having a hard time going to a particular site, you are advised to clear cookies because the cookies indicate that there is a session that's been kept, right? Some parameters for the session, and it could be referring to an old session. So you want to clear that and then allow the device to initiate a fresh one and keep those parameters. So in the standard HTTP header, right, that's cookies, URL parameters and rewriting that's defined in this particular RFC and URL argument on get post. Now, application developers also use body arguments as post requests. Remember, post in HTTP, post is usually sending data to a server. Get is asking the server to you're requesting. So they can go ahead and use hidden fields or proprietary headers. One of the most widely used session ID extend mechanism is cookies. Cookies offer advanced capabilities that are not available in other methods, right? So the cookies in this case just keep the conversation that occur within the different guys. So this is where hijacking of sessions begin. So let's look at it this way. The client, right, initiates a TCP connection by what we talked about yesterday to be perhaps synchronization, right, and acknowledgement and all of those. And while they do that, the session is now available. This guy knows, okay, this client knows this server is available. So it goes ahead to now indicate post, which is putting stuff. So in this case, it's posting information. It's sending data to the server for the purpose of verification. What he's sending is username Omar, and then the password is bad password, for example. Of course, this particular server will now create a session for this credential and then attach that ID to that cookie. That record of the credentials exchange between them is what it keeps and adds the ID to it. Then it returns that cookie to the client. So the client can keep that cookie. So each time this guy initiates that session again, it can go ahead and refer to what was there before. Okay. Then he will now send the cookie with a request saying, oh yeah, based on the conversation we had though, here's what, and then this keeps going on. So it creates a session, attaches the cookie, and then gives the response. This keeps happening each time as long as you are stuck online. Now, the session ID used by the most common web application development framework can be easily fingerprinted. In this case, you can indicate what we're using. Remember, we talked about how, for example, in this case now, easily fingerprint these development frameworks and languages by using the following sessions. This is PHP. This is Java. So sometimes the session ID is included in the URL. The dangerous practice can lead to the manipulation of ID or session fixation. So all what we've explained now allows for a record to be kept. So if somebody were to hijack that session, remember that there is already a conversation occurring between the client and the server in which they're referencing that ID. So web development frameworks such as ASP.NET, PHP, and Ruby or Rail provide their own session management features and associated implementation. So some guy can hijack that conversation occurring between the client and the server. You have to remember to encrypt the entire web session with HTTPS, not only for the authentication process where the user credentials are exchanged, but also to ensure that the session ID is exchanged only through an encrypted channel. Using an encrypted communication channel also protects the session against some session fixation attack in which the attacker is able to intercept what has already been manipulated, right? And then inject it into the session ID since he already knows that what the server and the client will do is just exchange session ID. So it's like identified as a bag that is allowed to be passed in. So I'll just inject something into the bag and allow the bag to be passed without really checking it. So there are two types of cookies. Like we said, there's a persistent and then a non-persistent. The persistent are the ones that actually stick to the browser until perhaps what is injected into it as the what's it called, termination time expires, or right, it just terminates, shut down, or the non-persistent cookie, which is usually the one that doesn't stick. The moment there's any interruption to the web browser or the connection between client and that particular server, the session expires. Ladies and gentlemen, we've come to the time, right, allocated for this session. Unfortunately, we cannot continue beyond now. Today is a Sunday. Some people need to rest, right? So let's attempt to look at all of this and try to read them. So I don't want to go to. We dealt with Kerberos in module 5. So for better understanding, refer to that again with reference to ticketing, which happens inside wired and wireless network. Default credentials, common and all. I apologize. We cannot go beyond this point anymore. The time is 10 o'clock already, and you guys have tried. So let's try to catch some rest. Unfortunately, that is what we can cover for this particular module. Please, like I always ask, I appreciate the people who are asking questions in the group. It's putting me on my toes as well because I'm constantly going back to revise my content and so that I can respond to some of you. So if you observe I'm not responding, it's because I'm also engaged in something somewhere. So apologies. Thank you very much. Thank you very much. So see you guys next week. So as it stands today, this is module 6. We have modules 7, 8, and 9, 7, 8, 9, and 10 to go. All things being equal, we should conclude by this time next week. And then from that point on, I'll leave you guys to do your work and ask questions. Okay, it's not just me talking back to you guys. So thank you all very much and see you in the future. Enjoy a great week. I hope this was informative. I'd like to thank you for being part of this class.